let's have a review of what we have had last week about second order linear differential equations. As you may remember, the general form of a second order linear differential equation is looking something like this. And we always try to keep the constant of y double prime equal to 1. To make it sure that we already have a y double prime, so it is not going to be 0. Because if it is 0, the coefficient of this y double prime, then this is a first order linear non-homogeneous equation, and we have talked about them. So we are keeping this one, so we are sure that we are dealing with a second order differential equation. Let me call this a star, and I will come back to this again and again. If r of x is equal to 0, then the star is called homogeneous, and what was the general solutions of a homogeneous equation?
Y equal to the
Yes, y of x equal to y gx, which is depending on two parameters. These two parameters are actually coefficients of two solutions, y1 and y2, and can I really write this general solution in this form? I can only do it.
y1 plus y2 plus c.
No. Last week you were absent, so yeah, you have some thread. That's why we are also making a review. If we are having a second order differential equation, then our solutions, the general solution, must depend on two parameters, okay? These y1 and y2 are two special solutions for our equation. If you plug y1 here, then this equality is satisfied. If you plug y2 here, it is again satisfied. And in the case that it is a homogeneous equation, okay, linear combination of solutions are also solutions. But the problem is that when I'm writing this linear combination, am I sure that I'm exhausting all of the cases? Does this contain all of the solutions for the homogeneous equation or not? We have talked about it, and the answer is yes, when they are not the same. But when we are saying they are not the same, up to what sameness? Here we need to define what is the same to function. Yes, exactly. If they are linearly independent, so I can write this as equality, then y1 and y2 are two linearly independent solutions for the homogeneous case. Today we are also going to talk about non-homogeneous cases. What was it? Equivalent formulation for these two functions to be independent? Yes. They are independent either if you divide them to each other, and the result is going to be a constant. For instance, e to the power of x and 2 times e to the power of x. Okay? If you divide these to each other, then you are going to get a constant, which means that this function is a constant multiple of the other function. y2 is c times y1. This means that linear dependency exists between them. But we do not want them to be dependent. We are requiring their linear independence. So, when you divide them to each other, it should not be a constant. Or, we can say that their Wronskian
is not equal to 0.
Then yes, when they are independent, is not equal to and this is defined as the determinant of y1, y1 prime, y2, y2 prime.
Is it determinant or just the matrix?
Determinant of this 2 by 2 matrix.
What do you mean by
By determinant, I mean determinant of a matrix. If you have a 2 by 2, actually determinant has a general definition, but for a 2 by 2 matrix, which we show it as this A, B, C, D. You see the changes? I'm not writing big parentheses, but just this is defined as AD minus BC. Okay. Here, what we need is to calculate y1, y2 prime minus y1 prime, y2. And we also know that Wronskian is either equal to 0, no matter what is your x coming from this y1 and y2, or it is not equal to 0. Okay? Yeah, it is not a function that in this interval is going to be either 0 or non-zero or having some roots and
Because
so
it's
on.
going to be 0 unless the two components are equal to each other, so it doesn't matter first.
Not that exactly, but you have a good intuition about it. Yeah. Okay? Okay. The thing is that we first talk about homogeneous equations. And by a homogeneous equation, homogeneous linear equation, I mean, this is also an abuse of naming convention, by the way. We're using this for different contexts, but you are aware that what are the differences? We have talked about homogeneous functions and first order differential equations with homogeneous functions. That is a different concept. When we are talking about a linear equation, and when we call that linear equation like this homogeneous, it means that the right hand side, the thing which is not coming with any one of the y prime or y double prime or higher order derivatives, that is equal to 0. Okay? Like what we have here. For the homogeneous case, since it is a second order differential equation, we are going to find two linearly independent solutions. Okay? If it is not homogeneous, which means that if Rx is not equal to 0, then solutions are yx equal to ygx c1 c2 plus yp of x. This is called the particular solution. Particular solution. And it is a solution that cannot be acquired by giving some values for the parameters C1 and C2. Okay? And this one is general solution of homogeneous equation. Okay? Our first approach in solving second order differential equations is that, first of all, we need to identify the type of equation that we are dealing with. And the first question here is going to be important for us, is the problem of this equation being a homogeneous equation or not a homogeneous equation. Okay? If it is homogeneous, we find two independent solutions, we write their linear combination, and then we are done. If it is not homogeneous, which means if it is this case, first we will assume that the equation is a homogeneous equation. We will assume that this is equal to 0, and solve that reduced homogeneous equation to find out about this answer. Then we will use some methods in order to find out this particular solution. Today we are going to talk about this particular solutions and complicate them. Okay? Now, when we are talking about solutions, our first approach is that need to guess and check. Exactly. In the homeworks, you will also have this kind of examples, right? An equation is given, two solutions are provided to you, and we are asked you to please check if there are solutions of these equations or not. And what you need to do, you need to take the function itself, take its first derivative, take its second derivative, and plug it into the equation that is given, and check that if the left-hand side and right-hand side are equal to each other. Okay? In the case of homogeneous equations, to check if this is equal to 0 or not. And if it is equal to 0, which means that if there are two solutions, then you need to check for linear independence of them. Yes. Okay? If you have the two solutions for homogeneous equations, you have guessed them and checked them and they're working, you need to then check for their independence. If they're independent solutions or not. If they're independent, which we can check in either ways, either divide these two functions to each other, and if it is not a constant, it is a function of x changing, then they are linearly independent, or you can equivalently check the Wronskian of these two functions. If Wronskian is not equal to 0, then they are independent. And the general solution, and the general solutions are going to be the linear combinations. Okay? But if we can only check one solution, if we can find only one solution, y1, then what?
We use the Vx or the
Yes, exactly. Use one solution to find another.
which is Vx equals to 1 over the first solution power 2 multiplied by Vx.
Correct me if I'm wrong. I want y2 of x to be a function times y1 of x. Why I need this to be a function of x and not a constant? If it's a constant as c, then y2 divided by y1 is just a constant, right? Then they're linearly dependent to each other. But I want it to be linearly independent. So I need this constant to not to be a constant, to be a function. So if I divide this y1 by y2, then I do not have a constant. Which means that I'm some kind of imposing linear independence on these two functions, okay? Then my second solution, if I have one, is coming in this way with over v, if I'm not remembering it wrong, it was 1 divided by y1 to the power of 2 e to the power of minus integral of px dx dx. Right? Yes. If we have one solution, how can we find another solution which is in the plane? And it is like this. Okay? If you have two solutions, y1 and if we have no solutions, then what? Oh.
We make equation of squared. We make an equation of
Not always. Just wait. I will come to it. I will come to it. Can you please take your phones off and take a picture of the board? Can you please take a photo of the board before I clean it? Telefon kullanıyorsunuz en azından geçen böyle bir şey yapmayın da çektiğim hepinize. Fine? Is it clear what is happening up to now? The general solutions for homogeneous equation come like this. The general solutions for non-homogeneous equations come like this. What is the first step? I need to find two solutions. If I find two solutions, which I mean by checking them, then I will check for linear independence. If I have been able to guess, or if I have been able to find two linearly independent solutions, then good. If I only have been able to guess one solution, then I will use this formula to calculate B, and my second solution is going to be this function. Okay? What if we do not have any solutions? This means that we need to now study special types of differential equations that we encountered. Two special cases of the classes of second-order differential equations that we are going to study is, first, linear equation with constant coefficients. Okay? And the second one is the Euler-Cauchy equidimensional equation. We will talk about two of them today. Then we will talk about this particular solutions of differential equations. How can we find them? Especially in the case when we have equation with constant coefficients. Okay? So, linear second order equations with constant coefficients. What is the general form of this kind of equations? Y double prime plus py prime plus qy equal to 0. And we're talking about the homogeneous case, because if it was even non-homogeneous, I would again make it reduced into this homogeneous form, find the general solutions for this, and then look for particular solutions. Anyhow, here our P and Q are just some fixed real numbers. Okay? How did we solve this equation? Again, what we have done is that we try to guess some solutions, right? And for that, we said that, okay, let's our y be this kind of a function, e to the power of mx. Why we made this kind of a guess? Because I want the function itself to be added to its derivative, to be added to its second derivative and become 0. It means that taking derivatives should not change the type of the function. Polynomials are not like this, for instance. X to the power of 3, if I take the derivative, then it is a polynomial of degree less. The type hasn't changed. Or if it is sine of x, if I take the derivative, then it is cosine of x. Okay? But here, I'm able to keep the type of the function itself, except for some coefficients that are being multiplied with. If this is a solution, then what happens? If I take its first derivative and second derivative, and if I plug it in this equation, then it must satisfy the equation, right? So what is our first derivative? M e to the power of mx. And our second derivative is going to be m to the power of 2 e to the power of mx. Okay? We place it in the equation, then what do we have? We have m to the power of 2 e to the power of mx. E to the power of mx, I'm taking a factor out of it, plus pm e to the power of mx, again we are keeping it out, plus q times e to the power of mx, which is going to be equal to 0. Okay? Now what happens?
We divide the whole equation to e power of mx.
No, why not? We have something multiplied to something x, and it is equal to 0. Can this function be equal to 0?
Yes.
So the only case that this equality holds is what? When this is equal to 0, right? And when this is equal to 0, this is equal to 0 exactly the time that m is equal to the roots of this second order polynomial equation, right? We call this characteristic equation. Characteristic equation of linear equation with constant coefficients. Okay? How can I find my m1 and m2?
Minus b
Minus b plus minus
plus
b
minus
squared minus 4c.
E to the power of 2 minus 4q divided by 2. Okay? What? Evet. This is our delta for this equation. Using different notations always makes some mixing in the thing, but look at this like this. X to the power of 2 plus px plus q equal to 0. Now you can solve this, right? A is equal to 1, B is equal to P, C is equal to Q. This is exactly the same formula. What was the cases then, if this kind of thing happens?
if b squared minus 4q positive, if it's 0, it's negative.
Yes. We can have 3 different cases right here. Case 1. When we have m1 not equal to m2, 2 real distinct roots. When this happens when this, or equivalently we can say that p to the power of 2 minus 4q is greater than 0. But when you're dealing with equations and you're trying to solve them, you're not going to check this. You're just going to form this equation and try to just solve the roots and try to see, okay, do I have 2 different real roots? Do I have a same repeated root, or do I have complex conjugate roots? Okay, but then this is also something to check. In this case, what is my general solution? The general form of my solution for this homogeneous linear second order differential equation with constant coefficients?
c1 multiplied by e and x.
Yes, I want to look for 2 functions that are working here, right? If instead of this m, I just put that number m1 and plug it again into the equation, is it going to be equal to 0? Yes, it is going to be equal to 0 because m1 is making this equal to 0. So the equality is going to be holding, which means that e to the power of m1x is a solution here. What about e to the power of m2x? Yes, again they are going to be a second solution. Are they essentially different functions? Which means that if they are linearly independent or not, and if you divide them to each other, since m1 and m2 are not equal to each other,
It won't give us a constant.
yes, so they are actually linearly independent. Since they are linearly independent, I can write this as, the general solution as m1x plus c2 e to the power of m2x. Okay? We have discussed about this, so that's why I'm passing. Our second case is that m1 is going to be equal to m2. In this case, our p to the power of 2 minus 4p is equal to 0, which means that m1 and m2 are going to be just minus p divided by 2. One real repeated root, or equivalently when p to the power of 2 minus 4q is equal to 0. Okay? In this case, what happens? What is my general solutions. Can I write this as C1 times e to the power of m1x plus C2 times e to the power of m2x?
No, because M1 and M2 are equal, so we need to put x beside the second.
Yes, definitely. Since these two are the same, so they are not linearly independent. One is 1 times the other. So this is not a good idea. So how can we find the next solution, the second linearly independent solution? We use that v, which we calculated by the formula, this one, 1 to the power of 2, e to the power of e to the power of minus px, dx, dx. And for this case, when we are having this equation, this v of x is going to be equal to x. If you do the calculations, we have done it last week. So what is our y2 then? It is x times our first function. So it is going to be c2 x times e to the power of m1x. Or you can write this as c1 plus c2x e to the power of m1x. Whatever works.
I know we don't like us memorize stuff.
Yes.
Is it better to memorize it like
This one, yes. This one, maybe memorizing is a good idea. But I myself is still, after writing it, I'm just getting to.
I'm just of the general formulas.
No, not the general. You need to know that for finding the general solution, we need to have two linearly independent ones. If it is an equation with constant coefficients, you can just write this, plug, and do the same things. Here, the important thing is that you can be able to form the characteristic polynomial. If you can form the characteristic polynomial, then based on the solutions that you get for the roots, you can see what is going to happen. If you have not seen the derivation of these formulas, yes, then it's going to look like that you're memorizing. But you have been deriving these formulas. This week you're also going to do, but for another case. But anyhow, that's the case. If you derive it one time, then you're going to easily get to understand what's happening over there. Okay? Please. Here, this is actually the plastics thing, but let's do it. What is my Vx? This formula, right? What is my first solution?
E power m1x.
Yes. Instead of that m1x, I know the value of m1, right? Based on this equation. If here my p to the power of 2 minus 4q is equal to 0, then m1 and m2 are minus p divided by 2. I know the values. So it is e to the power of minus p divided by 2x. This whole thing to the power of 2 multiplied by e to the power of minus integral of, what is our px in our equation?
P.
It is just this constant p. If you look at the general form of second order linear differential equations, y double prime plus pxy prime plus qxy equal to rx, right? And here instead of px, we have this constant function p. Okay? So it is going to be p dx dx. Now, let's make simplifications. What is this? If this 2 is multiplied to this one, I have e to the power of minus px, right? So I have e to the power of minus px. Here, what is this integral? P is again a constant. Take it out of the integral. Integral of dx is x. So this is e to the power of minus px. E to the power of minus px with this dx. Then what do I have? This one and this one cancel, and I'm calculating integral of dx, which is 1. And we suppress the constant of integration because we are just going to use that coefficient here in the general solution. Okay? So this is not 1, this is x. Sorry.
Integration of 1?
Yes. I integrated 1 dx, so it is x, not 1. Sorry. Okay? So our second solution is going to be by using the method of finding another solution by having 1. X times the first solution, which is x times the first solution. Okay? Let me clean here, because I need to also write the third case. What happens if we have m1 equal to a plus ib, m2 equal to a minus ib? Two complex conjugates. Two complex conjugate roots. And this happens when we have this p to the power of 2 minus 4q, it is less than 0. Okay? We have talked about this and we have used Euler's formula. I'm again going to use it, that's why I'm just making this review and going back. What we are going to do is that in this case, our general solution is going to be e to the power of this a x times, yes, c1 times cosine of dx plus c2 times sine dx. Actually, my y1 is e to the power of ax cosine of dx. My y2 is e to the power of ax sine of dx. And since these two are linearly independent, I can write the general solution as the linear combination of these two. Okay? This was almost all of the things that we have talked about last week. We have been able to derive all of these formulas. We have been doing all of the analysis and deriving the formulas about the V and Wronskians and so on and so on.
More examples and guess a check.
Yes, but this is just the general summary of what has happened last week. Okay? Again, if you could please take a picture of the board, I would like to clean it so we can start our new material. So our story is like this. If we can check the two solutions that we guess about a second order differential equation, then lucky us, good for us, and everything works super fine and we have nothing to worry about. If we can guess only one solution, then we try to find another solution as well by calculating that V. If we do not know how to guess a solution, then we need to some kind of study special cases of equations. The first special case was that second order differential equation with constant coefficients. And we have been able to derive what was the type of the solutions and so on and so on. The second, a little bit complicated than the thing, is this Euler or Cauchy's equidimensional equation. Okay? Let me ask you first a question. Is this a second order differential equation or not? Yes, it is. What is P of x here?
Isn't it supposed to be p of x over x
Yes, exactly. If you do that, what is the px for this equation then?
Px.
Yes, p divided by x.
Oh, that's not.
Write everything with x to the power of 2, so this is in the normal form, which means that y double prime's coefficient is equal to 1. Okay? What is then our p of x? Px divided by x to the power of 2, which is this one. What is q of x? Q divided by x squared. What is our r of x? So is this a homogeneous equation or not? Yes, it is a homogeneous equation. Good. Since that it is a homogeneous equation, I need to find two solutions, y1 and y2, which are linearly independent. Then I need to write their linear combination. And this way I will have the general solutions of this differential equation. Okay? Again, we will start by guessing some function as our test case, so we can derive some kind of a general idea about what's happening. What kind of functions do you think that it is better to select as our testing solution? Is e to the power of mx, for instance, is it a good idea to use that here? Or do you have any other ideas, better candidates for our solutions? I am trying to some kind of guess a type of solution, okay? I'm trying to check if it works or not. If I check y equal to, for instance, sine of x, do you think it is going to be a solution or not? Okay, so what type of functions we are selecting? What is that 2x? Is it trigonometric function? Is it exponential function, or what it is? What is the type of that function, and why you are doing this kind of things?
X power 1, I don't know how, what's the name of it?
Yes.
Because
Fine.
when in each time we'll make a derivative, the power will get less, so we're multiplying it by x each time to
Exactly.
balance it.
Yes. Because you know, if you have this, what is the first derivative? M x to the power of m minus 1, right? And if I plug this here in the equation, this x is going to be again multiplied by this one, so it is going to be x to the power of m. What is my second derivative?
1 multiplied by n minus 1 multiplied by x power of n minus 2.
Yes. This is our checking. Now, since this is a solution, let's put it inside the equation and see what happens. If you write this x2 multiplied by the second derivative, I'm just going to have m minus 1, m minus 1 multiplied by x to the power of m, right? I'm taking a factor out of that x to the power of m. Writing it here. Plus, what do I have here? Px multiplied by this one. So it is going to be Pm x to the power of m. X to the power of m, I'm writing it here. And Pm, I'm writing it here. Plus, if instead of y, we write x to the power of m, what do I have? I have qx to the power of m. And that x to the power of m, I'm writing it outside here. This must be equal to 0. Okay? This number multiplied to this function x to the power of m is equal to 0. When this happens, no, a number times this function is equal to 0. This must be the number 0, right? So our characteristic equation for Euler or Cauchy's equidimensional equation is going to be, let's write this again in the general form of a second degree polynomial equation. What is this going to be? I have an m to the power of 2, right? Minus m plus pm. And if I take a factor out of m, this is going to be p minus 1 times m plus q equal to 0. Okay? What is the difference of this one with the characteristic equation of equation with constant coefficients?
The minus 1 beside the m.
Yes. This coefficient of m, here, there it was p, here it is p minus 1. Characteristic equation of Euler's equation. Euler has been publishing so much material. I think he's still there printing some of his papers. And he has been working on a lot of topics that normally the second person after him, which is studying that topic, they're calling or the naming of that topics based on the second person. After Euler, Cauchy has studied this problem. That is why we call it also Cauchy's equidimensional problem. And you can find many kinds of this kind of things about Euler's work that is named after someone else, a second person after Euler. Anyhow, what should I do next? M burada ne oluyor? M'den yorumlanıyor. Ben bir test case olarak aldım. Bu bir test fonksiyonu. X üzeri benim cevaplarım olabilir mi? Evet olabilir. Ne zaman olabilir? Eğer ki denklemin kökleri varsa. So what is our cases then? Yes, again we have an equation, right? And we need to check for the values of m that are coming from here. What is our first case? When this equation has two real roots, right? Two real roots. Two real distinct. When this happens, if we want to write, let me just put this one here. From this equation, what is my values of m1 and m2? What are my roots? They're equal to
1 minus e plus minus.
Yes, minus this coefficient, which is going to be 1 minus p, plus minus the square root of this to the power of 2 minus 4q, p minus 1 to the power of 2 minus 4q, divided by 2. Okay? This is our roots actually. When we have two distinct roots, then what happens? This p minus 1 to the power of 2 minus 1k, this is a positive number. Okay? So what is my y1? First candidate for a solution, it is x to the power of m1. And what is my second candidate for a solution? X to the power of m2. Okay? Can I write the general solution as c1 times x to the power of m1 plus c2 times x to the power of m2?
Seems yes.
Seems yes. How can we be sure? What was the condition for me that if it was satisfied, I could say that, okay, then the solutions are the linear combination of these two?
That they be independent. If they
Yes.
were independent, then m1 and m2 aren't equal.
If these two functions are linearly independent, then I can write this. So, question, is y1 and y2 linearly independent? How can we check them? Just divide them to each other. If this is a constant, then they are linearly dependent and not linearly independent. If not, then they are linearly independent. What is y1 divided by y2? x to the power of m1 divided by x to the power of m. This is going to be what? X to the power of.
M1 minus M2.
Is this equal to 0? Why it is not equal to 0?
Because x isn't 0.
But what about x to the power of 0? Or if it is constant?
X
Not 0, sorry. I mixed it. Is it constant or not? I confused it with Ransky for a second. So the question is this a constant or not?
It can't be a constant because M1 and M2 aren't equal.
Yes. We have two real distinct roots, which means that M1 is not equal to M2. Which means that this is not 0, which means that this is not 1, which means that this is not a constant. So it is not a constant. So this one and this one are linearly independent. Or the second way to check if two functions are linearly independent or not was what? Calculating the Ransky of these two functions, M1 and M2. And this is going to be the determinant of the first function, derivative of first function. Second function, derivative of second function. Can you please calculate this Ransky and let me know if it is equal to 0 or not? Yes, of course. That's why I'm asking you. So is x m1 multiplied by m2 x m2 minus this, is it equal to the 0 function or it is something different? One point that just a few people mentioned, when we are taking derivatives, this is minus 1, minus 1. Okay? Anyhow, so they are linearly independent, right? So we can write this. Which means that I can also write this equality and the dominance. Okay. What is our next case?
Delta is equal to 0.
Yes, when this characteristic polynomial is going to have two same roots. Real equality. Which means that m1 is equal to m2, which is equal to which? If we have
1 minus b over.
yes. 1 minus b over 2. And when this happens when b minus 1 to the power of 2 minus 4q is equal to 0. Okay? In this case, what is our candidate solutions y1 of x and y2 of x? y1 of x is x to the power of m1, which is x to the power of m2, which is x to the power of 1 minus b divided by 2. Okay?
Should we simplify it by adding the root or no? It's
Adding the what?
replacing the over 2 by a root. Will it be simpler or more complicated?
Then you are going to make the function something different. You should avoid changing this thing, because if you are allowed to change this too, then you can also change this, right? And the whole point of finding this m1 and m2 is to be able to find exactly what is this. If it can be anything, then okay. What about the second solution? How can we find the second solution?
We need to multiply it by something with keeping it independent.
Yes, that we need to find it, right? This was our case. If we can guess two linearly independent solutions, then the general solution is their linear combination. If I'm able to only guess one solution, and we haven't been able to guess it, because if you take this, in this case, and plug it here in the equation, with this assumption, you will see that okay, this satisfies this second order differential equation, which means that this is the solution. But I'm not able to guess another one. Why here multiplying by x doesn't work? If I multiply this by x, that's going to be x to the power of m1 plus 1, or x to the power of p plus 1 divided by 2. Okay? Which means that it is turning this into this case with two different exponents for our x, and it is not working. Which means that in this case, our v of x is also going to be some other function. What function? I don't know. What we need to know is that the formula for vx is the first solution to the power of 2 times e to the power of minus px dx dx. We need to calculate this. If we can find this, then we can find another second solution. So let's do it. We are going to calculate the integral of our first solution to the power of 2. What is our first solution to the power of 2?
Which
X.
is 1 minus p.
Yes, which is going to be,
X power.
but let me write it first, then we can cancel this out. Multiplied by e to the power of integral of minus. What is our p of x for this equation?
P over x.
P over x, yes. P over x, dx, dx. And what is this equal to? This I have it as it is, so this is x to the power of 1 minus p. Right? But what is this integral?
The p is a constant. It
Yes.
will go outside.
So this is going to be e to the power of minus p integral of,
1 over x, which is ln of x.
yes, ln of x. And can I write this as e to the power of ln of x to the power of minus p?
But once that cancels the e and the ln x.
Yes, and since exponentials and logarithms are inverse functions, this is going to be equal to x to the power of minus p. Okay? So here I can write this as x to the power of minus p dx. What is this then? Is this integral of 1 over x dx or not? This is x times x to the power of minus p in the denominator, and I have x to the power of minus p in the denominator. So that will cancel, and I have 1 over x dx. And this is equal to ln of x. Okay? If this is our v of x, then what is our y2 of x? It is v of x times y1 of x, right? Yeah, it's the same. Which is going to be equal to times x to the power of 1 minus p divided by 2. Okay? Is this clear? How did we calculate this v? Is it clear? Let me get rid of it. If you have any questions, let me explain. Otherwise, let me clean here and
Should we take a photo of this?
if you want, yes, definitely take a photo. And I will just write the general solution as well. Then I would like to take a photo, but anyhow. This week we have used to calculate our second solution. Now, question. This is the first candidate. This is the second candidate. And you can really check that they are solutions, because if you take the derivative and plug it in this equation, you will see that this one is a solution, this one is a solution. Now question, is this two functions y1 and y2, are they linearly independent or not?
Yeah, because if we divide them up each other, it will be ln of x, which
Yes.
is going to be 0.
It is either ln of x or 1 divided by ln of x, and it is not a constant.
Aren't they have to be 10 or whatever
In this case, when m1 is equal to m2, we have this. Yes, based on the different cases, you have this. Okay? That's the point. So, since these two are linearly independent, either by division or we can also calculate the Wronskian, and you will see that it is not equal to 0. As an exercise, you can do that. Since these two are independent, then in this case, the general solutions of this homogeneous equation is going to be y dx c1 c2 equal to c1 times y1, which is x to the power of m1, or 1 minus p divided by 2, plus c2 times
X minus C.
yes, x to the power of 1 minus p divided by 2 times ln of x. If you take a photo of the board, I will clean it and I will move the surface. What is our next case, by the way?
When the delta is less than 0.
Yes, or when we have complex roots. Our third case is two complex conjugate roots. And it happens when p minus 1 to the power of 2 minus, let's use this then. Okay? If our m1 is equal to a plus ib, and if our m2 is a minus ib, for I to the power of t equal to minus 1, okay? Then what are these candidate solutions for our equation? We have y1 equal to x to the power of m1, right? And I can write this as x to the power of a plus ib, which I can write as x to the power of a, x to the power of ib. Now, can I write this as e to the power of ln of x to the power of ib? Can I write this in this form or not? Exponential and logarithms, they are going to cancel each other, so I'm going to have x to the power of ib, like what I have here. And this ib, I can write it as a coefficient for ln of x, right? Because we know ln of x to the power of a, or not this a, let's say something different. ln of a to the power of b is b times ln of a, if you remember this. Exactly the same thing that you're doing. And what can I write here? Do you remember Euler's formula that we have used also? E to the power of I theta was equal to cosine of theta plus I times sine of theta. Right? Instead of theta, what I'm going to write? B ln of x. So this is going to be x to the power of a cosine of b ln of x plus I sine of b ln of x. This big parentheses. Okay? What about my second candidate? I can also do the same, but this time here I'm just going to write minus ib. So it is going to be x to the power of a, e to the power of I minus b ln of x. And if you replace, then you will see that this is going to be x to the power of a cosine of minus b ln of x, which is equal to cosine of b ln of x. And this sign, that minus is going to get out. It's going to be I sine of b ln of x. But if you look at here, we are again dealing with some complex numbers. And since we are looking for the real solutions, we need to make a linear combination of these two such that these i's are going to disappear. What I'm going to do is this. Again, like for the case that we did for equation with constant coefficients, if you remember. I'm selecting this curly y as y1 plus y2 divided by 2. And if we do that, then this one is going to be x to the power of a cosine of b ln of x.
Why did we select that? I didn't understand about
Why did we select it? Because, you see, this is a complex function, right? We have some complex numbers. But I want to make linear combination of these two functions such that my function is not a complex valued function. It is a real valued function. So I'm trying to get rid of this i's in simple cases. How can I do it and get two different linearly independent real functions?
Can't I just say like make it something with like e power of e theta?
E to the power of e theta.
Şey, şu şekilde söylediğimiz formül vardı ya, bunu bir şekilde şuna benzetmeye çalışıp y üzeri olarak yazabileceğim şekilde almaya çalışıp.
Yazdık işte. Onu kullandık ki o şekilde.
Ha, onu açtığımız zaman.
Aynen açtığımız için oraya geldik. Sen kapatırsan bir geri getirici olur. Değil mi?
Şey ama hala anlayamadım. Niye y
Çünkü ben şu kısmı çıkarmak istiyorum ve şu kısmı çıkarmak istiyorum. And in order to get rid of these i's, you see why I'm doing this? You're asking me why I'm adding y1 plus y10 divided by 2, right? Add them together, this one and this one. If you add it, this plus I sign and minus I, they cancel out, right? And I have 2 times this. So I divide by 2 to get this one. And for my second y, if I subtract this 2, these cosines are going to cancel out. And I'm going to have 2 times I times the sine of this. And if I divide by 2i, then I'm just going to get x to the power of a sine of b ln of x. Okay? Now, question.
What is the difference?
Is this one and this one? Is this two linearly independent functions or not?
Yeah, because if we divide them, they'll either be theta or
Yes. Or you can also calculate the Wronskian of these two functions. It is a little bit complicated, but if you do it, then you will see that it is actually not equal to 0. So, okay, so this is my candidate, the first one, this is the second one. So, my general solution is going to look like what? If you're okay with this, I'm just going to clean it. Because I want to have everything in one place. My general solution in this case is going to be equal to linear combination of this one, c1 times this one plus c2 times this one, which is going to be x to the power of a c1 times cosine of b ln of x plus c2 times sine of b ln of x. Okay? Good?
Can you make it
A cloud, yes, why not? Is this okay? Please take a photo of the board. Then we will solve some examples. Can you please solve this second order differential equation? What do we need to do first?
Make the coefficient beside the double prime as 1.
We need to first understand what kind of a problem do we have. Is this a second order differential equation or not?
Yes.
It is. Is it linear or not?
No.
Why not?
Did it, but not in the form.
So you can turn it, right? This is a linear one. What is our p of x?
2x divided.
2x divided by x squared, which is 2 divided by x. What is our q of x? 1 divided by x squared. What is our r of x? So is this a homogeneous equation? Yes. Since this is a homogeneous equation, I need to only find two solutions which are linearly independent. Can I guess any solution? Can I guess two of them? Or can I guess even one of them and try to find the second one by calculating b? Or, if I cannot guess any one of them, is this any type of an equation that I know?
You can guess. It's double shape.
Don't guess it, but we know how to solve this equation because we know this kind of an equation, right? This is not an equation with constant coefficients, but it is Euler's or Cauchy's equidimensional equation, right? So now we know how to solve it. We have spotted the equation and we know what type of an equation it is. So to solve this, what do we need to do? We need to write down the characteristic equation, find the roots, and based on that, try to see which one of the cases do we have. What is the characteristic equation of this differential equation? Aynen. M squared
Plus 2 divided x.
2 is our p, right? And our characteristic equation for Euler's equation was p minus 1 times a, which is 1 times m here, plus 1 equal to 0. What are the roots of this? What is m1 and m2? Minus 1 plus minus the square root of 4 times, not 4 times, 1 to the power of 2 minus 4 times 1, 1. Okay? Divided by 2. So what is our roots? Plus minus. And what should I write for this one? Minus 1 divided by 2 plus minus I times square root of 3. Okay? Which one of the cases is this? The third case, right? So what is my A?
Minus
Minus 1 divided by 2. What is my B? Square root of 3. Divided by 2, I also have this. You should correct me more often. Because, anyhow. So, what is the general case of our solutions? X to the power of minus 1 over 2. C1 times cosine of square root of 3 divided by 2 ln of x plus C2 times sine of square root of 3 divided by 2 ln of x. Good? two things you're mixing. The general case of this is the general case of a second order linear differential equation, right? Based on these px's and qx's and rx's that changing, and if you can select different functions, we are going to get different expressions. For instance, if in this case, you select p of x as 6 divided by x and q of x as minus 2 divided by x2, and r of x equal to 0. I'm selecting this like this. Then, what happens to this equation? This is y double prime. What do I have? Minus 2 divided by x2 y. Is this true? If I multiply this by x to the power of 2, then what I will get? I will get this one. Okay. Now, if I take this p of x, just some number, to q of x to your whatsoever, then what will happen to this equation?
Minus it by bx at minus 0.
This will become y double prime plus 2y prime plus 3y equal to 0. Right? So what kind of an equation is this? It is a second order differential equation with constant coefficients, right? You can also select these things very something different. For instance, take this as sine of x, take this as 2, okay? Then what kind of an equation I will have? Then I will have is this clear what is happening? This is the general form, the schema of the whole second order linear differential equations. And when we are talking about differential equation with constant coefficients, or when we are talking about Euler's equation, these are special cases of this general form. Okay? Now in this general form, if you select this function p of x as just a constant p, this q of x as just a constant q, and r of x equal to 0, then we are going to have y double prime plus py prime plus qy equal to 0. What is this? The general case of second order linear homogeneous equation with constant coefficients. What is p here? What is q here? They are just constant numbers as a special cases of these functions. Now they are not changing as exchanges, they are just constant and they're p's. Okay? Does it solve your problem regarding this small p and capital P? Good? Okay. Did you solve it? First, what is the procedure for solving this equation? Writing its characteristic equation, right? What's the characteristic equation for Euler's equidimensional equation?
Square plus b minus 1 plus e.
Yes. Whenever you see y double prime, you just write f to the power of 2 minus, you had p x y prime, right? And instead of p, what do we have? You have 6, right? So it is 6 minus 1 times m plus, you had q. What is our q? Minus 2 equal to 0. So what is my characteristic equation? M to the power of 2 plus 5m minus 2 equal to 0. Okay? Can you please find the roots of this equation?
Minus 5.37 and
0.37. What about the general case? Let's use the delta's method because
Here.
minus 5
Minus
Plus minus
plus minus square root of
5 squared. 25.
25 minus
4.
multiply by minus 2.
8. So it means that 25 plus 8. What is this? 33. Divided by 2. So we have two real roots, right? M1 is equal to minus 5 plus the square root of 33 divided by 2. And our M2 is minus 5 minus the square root of 33 divided by 2.
So is it okay if we have it in like decimal form?
Yes.
Then
But as long as we can understand that, what is the decimal form for this?
minus 5.3.
Just a reminder.
Minus, I think this one is the minus one.
This one is minus
So,
5. Yes, minus 5.3.
5.37. Okay, what about this one?
0.3.
0.37. Okay. Now, what is our general case of solutions?
YG X C1.
C1 times x to the power of m1. C1 x to the power of minus 5 plus the square root of 33 divided by 2 plus C2 times x to the power of m2, which is minus 5 minus the square root of 33 divided by 2, which you can also write as C1 x to the power of minus 5.37 plus C2 x to the power of 0.67. But the problem is this, When you're writing it like this, you're cutting it in some place, right? So I can write this as 37 divided by 100. And 37 divided by 100, it is not exactly the same, and it is not going to exactly be equal to. So yes, these numbers are actually these, but try not to use this form.
Besides, in the exam, we won't have a calculator to know that, so it's not
Yes.
fair.
But even if you had, if it is not exam, you should prefer to keep it in these closed forms, not to use.
Round, it will be true if I just put, into basic.
We are trying to look for solutions, so we are looking for exact equality. Don't write it like that, okay? Because if you have the exact solution, why there is need to work with approximate solutions, let's call it. Fine? One more example before break. Good?
Okay, but
Please ask if this is about this, please ask.
I just was about to say, I wrote the same, but I didn't show typo.
Can you please solve this equation? First, we need to identify the equation. Is it a second order equation or not? Yes, it is. Is it linear or not? If it is linear, so it follows the general form of a second order linear equation, right? What is our p of x? This is not writing. What is our p of x here? P of x is just a constant function for. What is q of x? Minus 3. What is r of x? 0. Yes. Is this a homogeneous equation? Yes, it is a homogeneous equation. So, I need to also understand the type of the equation. Is this an equation an Euler equation, or what do we see? This is a constant, this is a constant, and if you see that you have an equation with constant coefficients, right? Much better. Now, what is our characteristic equation that we need to write here? Yes, our characteristic equation is going to be f to the power of 2 plus, yes, 4m minus 3 0. Why? Because this is a second order equation with constant coefficient. This is not a Cauchy equation. I have some problems, right?
is M squared, but this one again M squared.
We have two characteristic equations. We have one characteristic equation for Euler's equation, for this equation, which comes as m to the power of 2 plus p minus 1m plus q equal to 0. We have also a characteristic equation that we have talked about last week, about the equation with constant coefficients. And what was the, is this an equation with constant coefficients or not? This is not this equation. This is not an Euler equation. This is an equation with constant coefficients. That is why I need to write down the characteristic equation for this type. And for that one, we had m to the power of 2 plus pm plus q equal to 0. As you have also seen in the beginning of the class when you reviewed. Okay? That is what? That is the point of it when, after two examples, I'm going back to this constant coefficients. You need to be able to distinguish between these two. What are the roots of these?
Two roots. Minus 4 plus square root of
Okay, let's do it together. M1 is equal to minus 4 plus square root of 16 minus, or 16 plus 12, which is 28, right? And our M2 is going to be minus 4 minus the square root of 28 divided by 2. Now, since I have two real distinct roots, what is my general solution? C1
multiply by x1.
Multiplied by
E square root.
e to the power of this m1 x. I'm not again writing m1, but we can plug it here. Plus c2 times what? E to the power of m2x, and this is our m2 that we can write here. Okay? So there are 6 cases. 3, 4. Second order homogeneous equation with constant coefficients. Cases are decided by the fate of the roots of this characteristic equation. And we have 3 cases for Euler's equidimensional equation, which we decide for that 3 cases based on roots of this characteristic equation. Okay? Let's have a break, and then after that we will talk about particular solutions of differential equations. Okay. Now that we have talked about homogeneous equations and how to find their solutions and the special cases of homogeneous equation, we are trying to now develop further methods in order to find particular solutions of this equation. It is an equation with constant coefficients, but the right-hand side is not equal to 0. It is some function. Okay? We normally use 3 different methods in order to find the particular solution of this differential equation. First of them is the method of undetermined coefficients. Okay? This is useful when the right-hand side is r of x is an exponential function, or a sine of bx cosine of bx, a trigonometric in this form, or a polynomial in this form. We are just going to give some examples, talk about all of them in detail, but let's try to first see the big picture, then we will zoom inside each one of them. Okay? The second method of finding the particular solution is the variation of parameters. It is actually a method developed by Lagrange. And what happens if you want to use this method? You need to be able to have 2 solutions, y1 and y2, of the homogeneous equation. Then based on that, we calculate something which gives us the particular solution. Or we can use the operator methods developed by Heaviside. We are going to talk about this next week, I think. I don't think we'll have the time to discuss about it, but anyhow, let's see what happens. Okay. So, the method of undetermined coefficients. Undetermined coefficients. When we have this kind of an equation, y double prime plus py plus qy equal to e to the power of ax. Okay? In this case, what is going to be my general solution? It is going to be y of x equal to the general solution of homogeneous equation plus this particular solution, right? We are interested in finding this. Okay? We have an unhomogeneous equation like this, and we would like to find this one. When we are having this method of undetermined coefficients, we normally look at the type of this function and we add some coefficients to this function, and then we will try to find that coefficient. That is why this is called the method of undetermined coefficients. Here, in this case, we call it case 1. Since r of x is e to the power of ax, consider y of t as a times e to the power of ax. Okay? What will happen then? If this is the solution, then we can plug it in the equation, right? We can have C1 equal to 0, C2 equal to 0. So this C1y1 plus C2y2 is equal to 0. And we have only this part. And we assume that this part is coming in this form. So if we plug it in the equation, what are we going to get? What is the first derivative of this?
Isn't there, it has to be like prime with the ty?
Yes, there is. Thanks. Our y prime is going to be capital A small a to the power of ax. Our double prime is going to be a to the power of 2 ax. And if we plug it into the equation, what we're going to get? We're going to get a. Let me also put the factor of the power of 2 into plus PA plus Q. A is in all of them. E to the power of AX equal to e to the power of AX. Right? Do you see what is happening? I'm assuming that my solution is a constant times this right hand side. Taking its first derivative, second derivative, replacing it in the equation. Left hand side is equal to this, right hand side is equal to this. If these two are equal to each other, then what will happen?
Then this equation must be 1 over a.
Yes, this whole thing must be equal to 1. And I was looking for a, right? A was my undetermined coefficient that I was going to calculate. So what is going to happen? A is going to be equal to 1 divided by 8 to the power of 2 plus PA plus Q. Yes? Yes. If you now take this number and you put it here, for instance, this 5, 7, or whatsoever, this is going to be a particular solution of that differential equation. Okay? This is true. Gelin bakalım. Oraya keşke şeyleri versin.
So what?
What? Can you hear? Yes. I can hear that, I cannot hear you. That's why. Saat kaç bu arada? 3. Dersimizin son yarım saatini bir uygulama ilgili bir şeylerle konuşacağım da astroloji ve astronomi hayranları varsa aramızda bunlarla konuşmayı çok isterim. Son yarım saatimizde kaçmayın ne olur beraber. Astroloji ve astronomi ikisini de biraz bir şeyler konuşmak istiyorum sizinle. Hayır, ben Do you believe in astrology? Google it. Linear astrology. Not linear astrology. O son yarım saat yukarıda çıkaran But that is the problem. If I don't believe in something which has some scientific roots and grounds, how can you make it good? This is the question. Of course.
Something in space can decide what
Astrology has grown out of astronomy.
Yeah.
Okay? Before the Enlightenment times, they were all the same science.
I understand that there is a standard that stuff exists in space, but it can't decide what will happen next in the future.
You're looking to the past from your idea that you have from today, right?
Yeah.
So it is looking backwards. I'm not asking about this. I'm asking looking forwards. How in the future this kind of things. About the importance of scientific methodology. Not anything else. Anyhow, we'll talk about it. Okay, sesiniz. Lütfen. Evet. Özel sorulara cevap vermez. Okay. So let me please continue. Arkadaşlar, konuşmaya aynı. Son saatte tutarsak daha iyi olur. So this is our case, except for the cases that this is going to be a root of this equation. And when this happens, then instead of having y be equal to a e to the power of ax, you should try equal to a x e to the power of ax. If it doesn't work again, you need to work with y of b equal to a x to the power of 2 e to the power of ax. Okay? This is our cases. So let me give you an example, and if you would like, please take a photo of the board so I can use everything and we can solve it. this equation, we want to try to find all of the solutions of this equation. What kind of solutions is this going to have? The solutions of this equation is going to come as solutions of the reduced homogeneous equation, which means when this is equal to 0 plus a particular solution. What is the solutions of this reduced equation when we consider this equal to 0? When we have y double prime minus 3y prime plus 2y equal to 0, then what is our solutions?
E power of x and e power of x and 2x.
Yes, we need to find the characteristic polynomial and its roots, right? What is the characteristic polynomial? M to the power of 2 minus 3m plus 2 equal to 0. From here, we can have
M minus 2 and M minus 1.
okay, so our m1 is equal to 1, m2 is equal to 2. So this yg of x c1, c2, this is going to be c1 times e to the power of x, 1x, plus c2 times e to the power of what? 2x. Okay? Now, look at this equation. No matter what you select C1 or no matter what you select C2, not no matter, now no matter. Let me first work with that case, then come to C. No matter what is your C1 and C2, you can never have a solution extracted from this general formula such that if you plug it into this equation, this equality is satisfied. Because this is a non-homogeneous equation. To the solutions of homogeneous equation, we need to also add this particular solution. How do we find this particular solution? We will assume that since this is an exponential, we can use the method of undetermined coefficients. We can assume that y of p is equal to a times e to the power of 3x. And then replace it and find this a. What is that a actually? If we take this first derivative, y prime, this is going to be 3a e to the power of 3x. If I take the second derivative, this is going to be 9 times a e to the power of 3x. Okay? Then what do I have? Just replace it in the equation. I have the second derivative, 9a. I'm also taking a factor out of e to the power of 3x. Minus 3 times this, which is minus 9 times a. Okay? Plus 2 times a, e to the power of 3x is equal to right hand side. What can I write from here? Next simplification. 2a is equal to 1, right? The coefficient of e to the power of 3x is 2a. The coefficient is 1. 2a is equal to 1. From here, what is our capital A? 1 divided by 2. So, from here, what is our particular solution? It is 1 over 2 e to the power of 3x. Okay? Which means, now, my solutions are, what was this general part? C1 e to the power of x plus C2 e to the power of 2x plus, what is this? Half e to the power of 3x. Now if you get values for C1 and C2, the solutions that you're going to get from here are solutions of this differential equation, okay, which is not homogeneous. If I have the case, is this clear? If I have the case such that this is equal to 2x, let's say, then what will happen?
That way, if C1 is equal to 0 and C2 is equal to 1, it would be easier, right?
Shall I select my particular solution in this form? You see, this is already included in this answer, right? Because if you take C1 equal to 0 and C2 equal to A, I have this. So this is not going to give me any additional particular solution here, because this is included in this. What we need to do is that we need to write this as x e to the power of 2x. If this also does not work, x to the power of 2 e to the power of 2x, right? I'm leaving it as an exercise to you. Find A. Okay? Yes, this is a new case. This is our case 2 for undetermined coefficients. If this is the right hand side is equal to sine of x or cosine of bx, any one of them. What should we do for general case? In this case, choose yp of x as a times sine of bx plus b times cosine of bx. Okay? And if the general solution is a linear combination of sine of bx or cosine of bx, then choose yp of x equal to x times a sine of bx plus what do I mean by this? You look at this, again we have this kind of an equation, but this time instead of e to the power of 2x, we have, for instance, sine of x. Okay? How can we find a particular solution for this one? We know that the general solution of this homogeneous equation is this. And if I'm looking at the non-homogeneous equation, to the complete equation, I need to also have this. Why I'm writing this as well? Then I'm needing to also find this particular solution, right? What should I do?
Can I ask something?
Yes, please.
Is there cos x or just cos
Yes?
Is it just cosec or cos px?
This one?
No, under. And plus, yes. Is it actually cos px or just cosec?
I have forgot to write it here. Who's a step that was. In this case, what should I do? Since I have a trigonometric function, I need to write my particular solution as in this form. So I need to write this as a times sine of 1x plus b times cosine of x. Okay? What is the derivative of this one? What is the derivative of a sine of x plus b cosine of x?
A cosine of x plus minus b sine of x.
Minus b sine of x, yes. And what is our double prime for this particular solution? It's going to be
Minus a sine of x minus b cosine of x.
Now I need to replace this into the equation. So what do I have? I have y double prime. Let me write it. Y double prime minus 3y prime plus 2y, which is equal to minus a sine of x minus b cosine of x minus 3 times this, which is minus 3 times a cosine of x plus 3 times b sine of x plus 2 times the function itself plus 2 times a sine of x plus 2 times b cosine of x. This must be equal to what? The right hand side, which is sine of x. Let me clean here. If you take a picture or a photo of the board, I can clean the board so I can continue from the right hand side. What is this then? What is the coefficient of cosine of x? Minus b plus 3b cosine, cosine, cosine. What do I have? Minus b minus 3a plus 2b, which is b minus 3a. b minus 3a cosine of x plus, what is the coefficient of sine of x here? Minus a, 3b, 2a. a plus 3b. This is equal to sine of x. What do we get from here? What is the coefficient of cosine in this side? It is minus 3a plus b equal to what?
0 on the other side.
0 on the other side. And a plus 3b equal to 1. Okay? How can we solve this system of linear equations? Do you know Cramer's rule, by the way? We can also, I don't know, multiply this by 3, add them together, and so on and so on. This is called the Gaussian elimination method, right? We can also use Cramer's rule Which means that first we need to write this in the matrix form. If I have my A, if I have my B, if I have my right hand side, which is 0 and 1, what is the coefficient of A in the first row? Minus 3. What is the coefficient of B in the first row? 1. Coefficient of A, coefficient of B. If you do this matrix multiplication, you will see that this is going to be exactly this one. Minus 3, 1, multiplied by this, which is minus 3 times A plus 1 times B. This must be equal to 0. And also 1 times A plus 3 times B is equal to 1. Okay? Cramer's rule states that A is equal to determinant of the matrix itself, which means determinant of minus 3, 1, 1, 3, and determinant of the matrix such that, is this the first variable or not? This is the first variable, right? In the first column, write this right hand side, which means that 0, 1, and the second column I keep it as it is. So what is this equal to? This is equal to 0 times 3.
Is it the rule?
Yes, Cramer's rule. 0 times 3 minus 1. What about this one? Minus 9 minus 1, which is going minus 10. What about B, or our second variable?
So sorry. Is there a name for that rule?
Cramer's rule. Okay? Again, we write the determinant of the matrix, which we calculated as minus 10. Here, now, since I'm dealing with the second variable that I'm looking for it, in this matrix, replace the second column with the right hand side. So it's going to be minus 3, 1, 0, 1, which is going to be minus 3 times 1, minus 0, which is minus 2. Okay? So if you come back to our equation here, this y of p here, this one is going to be equal to what? 1 over 10 sine of x plus 3 over 10 cosine of x. And this is the way that we calculate the solution for this non-homogeneous equation. Okay? In other case, when we are dealing with the method of undetermined coefficients, is that right hand side is a polynomial, like this. A0 plus A1x up to ANXN. Then we take yp of x as a0 plus a1x up to anxn. If q is equal to 0, then take yp of x as x times a0 plus a1x plus anxn. If p and q both are 0, then taking times the integral. Take 2 times integral. Why in this case taking 2 times integral work? Because you have y double prime equal to some function of x. This is already a separated one. So y prime is going to be integral of rx dx. And y is going to be integral of this. Okay? So 2 times taking integral will give us. Of course, we have the c's and so on. But anyhow, that is the case that we have already discussed about. Anyhow, what was my example? Y double prime minus 3y prime plus 2y or plus 3y minus 2y. What was this? Plus
3 plus 2.
Okay. Now if you have, for instance, this kind of an equation, and we are asked to solve this equation, what should we do? What is going to be our solutions like? Solutions of the reduced homogeneous equation. If this equation was equal to 0, what was our solutions? The general solutions?
C1 to the power of x plus C2 power
C1 e to the power of x plus C2.
C2 power of 2x.
But since this is a non-homogeneous equation, we need to also have this yp of x, right? If you want to determine this yp of x by method of undetermined coefficients, what we need to do is this. Since this is a polynomial, then we are going to take our yp of x equal to this a0 plus a1x plus a2x2. Shall I continue? No. Because if I write to the power of 3 and so on, since this is not appearing here, that coefficients are even at the end, they're going to be equal to 0. So up to this coefficient is fine. Okay? So what is our first derivative? a1 plus 2 times a2x. What is our y double prime? It is 2a2. Right? Now, let's replace it in the equation. Yes, please ask.
No, I see.
2a2 minus 3 times this, which is going to minus 3 times a1 minus 6 times a2x, okay, plus 2 times a0, 2 times a1x plus 2 times a2x to the power of 2. This needs to be equal to x to the power of 2, right? Let's collect the terms. Who does not have any x's? This one, this one, this one. So this is 2a0 minus 3a1 plus 2a2 equal to, that is going to be something. Let's just first write it as this. Plus terms containing x. This is going to be 2a1 minus 6a2x plus 2a2 x2 equal to x to the power of 2. Okay? Now what will happen? must be equal to 0. Coefficient of x to the power of 0 or the constant term, this also should be equal to 0. Okay? And by equating this and solving the equation, you will get to solve it. As an exercise, please do it. What I'm going to do is this. I'm going to change the question, right? This has 2x to the power of 2. Up to now, nothing more changes, right? Except that I need to write this as 2x2 and 2x. Okay? Now, yes. A2 is equal to 1. If A2 is equal to 1, 2 minus 6 A2 is equal to 0. So, what is our A2?
Wait, A2 is equal to 1. You mean what's our A1?
3.
A1 is equal to 1, yes. A2 is equal to 1, sorry.
A1
Yes.
is 3.
A1 is going to be 3. And if I have this 2 minus 9, which is going to be minus 7.
A0 is 7 divided by 2.
So, what is going to be our solutions for this equation? Solutions are y of x equal to c1 e to the power of x plus c2 e to the power of 2x plus my a0 is 7 divided by 2 plus 3 times x plus x to the power of 2.
One. Oh, that would be A1 by x and
Good? One more thing that I need to mention to you about undetermined coefficients. Yes, please, if you want to take a picture. Good? Principal superposition. Yes? Yes, but that is something different, superposition of waves and so on. Yes, you're right. The meaning of superposition will be clear, just let me write the things and... x y prime plus qx y equals to r x. If I had a particular solution for this equation, which I call it yp1. And if I have a particular solution for this equation, which I call it yp2, then yp1 plus yp2 is a particular solution of y double prime plus pxy prime plus qxy equal to r1x plus r2x.
wouldn't that lead us to another y general?
This means like this. I need to first of all check if this px and qx are constant or not. But if I'm doing the calculations correctly in my mind, it seems that it must work. But I need to check it. But anyhow, the point is this. If you have this second order linear equations with constant coefficients, this is the generalized version of that thing, such that right hand side, this r of x, which doesn't make it a homogeneous function, which is not equal to 0. For instance, it comes like y double prime minus 3y prime plus 2y equal to e to the power of x plus sine of x plus x to the power of 2, let's call it. Okay? For this kind of cases that we have addition of these exponentials or trigonometric functions of sine and cosine and some polynomials, you can behave this like this is a separate equation. Okay? This is a separate equation and this is a separate equation. And for one of them or different one of them, is it 1, 2, 3 or more, find particular solutions and then add them together. Okay? Good. Hızlıca şu metodun da üstünden geçeyim ve defteri kapatalım. Let's go on. Shall we? Okay. The second method that we need to use in order to find the particular solutions of second order differential equation with constant coefficients in the linear case, which is not homogeneous, is the method of variation of parameters that is developed by Lagrange. In order to be able to use this method, we need to first assume, or not assume, we need to first find, and we need to first know these two solutions for the homogeneous case. The method of variation of parameters is saying this. My particular solution is going to be a linear combination of this y1 and y2, but it is single slightly change of c1 not being just a constant, but a function, which we call it v1 of x, and the c2 also not being a constant, but a function. Okay? I am not going to derive the formulas, but if you assume that this is a particular solution for this non-homogeneous equation, if you take the first derivative and second derivative and replace it in the equation, you will see that with one assumption, which is this assumption, we are going to have a set of equations for v prime and v1 prime and v2 prime. y1 v1 prime plus y2 v2 prime y1 prime take the derivative of this one and collect the derivatives that contains this term, okay? Since we do not want to have the second derivative of v1 and v2, we assume that this is going to be equal to 0. This is coming from our assumption. And in the rest of the calculations, this is coming from the assumption that this is actually a solution, a particular solution for this differential equation. So we have this kind of a set of equations, right? Can I write this in matrix form? What I'm looking for, my unknowns are actually here, v1 prime and v2 prime. The matrix of coefficients are, what is the coefficient of v1 prime in the first equation? y1. What is the coefficient of v2 prime in the first equation? y2. What about the coefficient of v1 prime in the second equation? y1 prime. The determinant of this is the Wronski. Yes, you're right to notice that. This is equal to 0 r of x. 0 r of x. Okay?
Can I ask something?
Yes, please.
Why didn't we take y1 and y2 derivatives first and 2?
You're asking from where these equations are coming, right? Yes, exactly. This is why I didn't draw them, because if I was going, then it was a lot of writing and time. The thing is this. I assume that this is a particular solution. Which means that if I take its first derivative and if I take its second derivative, then this is going to be satisfying this equation, right? This one. The non-homogeneous linear equation with constant coefficients. If you take the derivative of this one, what will happen? v1 prime y1 plus v2 prime y2 plus v1 y1 prime plus v2 y2 prime. Isn't this the case? Derivative of this one plus this one, derivative of this one multiplied by this one plus derivative of this one. And I'm changing their order. You see what I have here? I have this term, right? If I don't assume that this is equal to 0, which is my first equation here, then when I'm taking the second derivative, then I'm going to also deal with second derivatives of v1 and v2. And I do not want to have the second derivatives of v1 and v2. That is why I assume this is equal to 0, which is my first equation. Then I take derivative of this one in order to get the second derivative. Then I replace it into the equation, and that will give me this equation. Okay? So it is where these two are coming. Now, okay, now, if this is represented in this matrix form, I can again use Cramer's rule, right? In order to find this v1 prime and v2 prime. What is going to be my v1 prime? It is the determinant of this matrix in which this column is replaced in the first column, because I'm looking for the first unknown, the time after. So it is going to be 0 Rx, and the second column stays as this. Divided by the determinant of this whole matrix itself, which is y1, y1 prime, y2, y2 prime. What is this equal to? Can you please calculate this determinant? Minus y2 rx, exactly. And what is this?
y2 prime y1 minus y1 prime.
Can I write this as Wronski of y1 and y2 or not? Is this equal to 0 or not? This is not equal to 0. Because since y1 and y2 are two linearly independent solutions of the homogeneous equation, this y1 and y2 are linearly independent, which means that the Wronski is never going to be equal to 0, which means that, yes, I can solve this system of equations. It has a unique solution, which is even minus. Okay? And what is my v2 prime based on Cramer's rule? Again, we have the determinant of our matrix, which is y1, y2, y1 prime, y2 prime. And here I'm calculating the determinant of what? This matrix. But since I'm looking for the second unknown, I need to replace the right-hand side with the second column. Which means I'm just keeping y1 prime, and replacing the second one with 0 rx. And what is this again?
y1 multiplied by rx.
Yes, y1 rx divided by again Wronskian of y1 and y2. Okay. So our particular solution is going to be what? v1 times y1. Let me write y1 of x. Instead of v1, what should I write? I have the derivative of v1. So v1 itself is the integral of this. So it is going to be integral of minus y2 rx Wronskian of y1 y2 dx plus y2 of x times v2, which is integral of this term y1 r of x Wronskian of y1 y2 dx. Okay? Is there any need for you to really memorize these formulas? No. The only thing is that, look at this. I have exactly the matrix which is looking like the Wronskian. I have derivative of v1 and v2. I have 0 and rx. From here, the rest can easily follow. If you also know how to use Cramer's rule. Okay? Anyhow. Example. If we have y double prime plus y equal to cosecant of x, for instance, can you please solve this differential equation? Herkesin you know. What is our steps? First, we need to identify what kind of an equation is this.
Second order.
Is it second order? Yes. Is it linear or not?
It's not linear.
It is linear. Why not?
Or y times.
The px is equal to
0.
Okay.
So is it linear or not?
Yes.
What is our px?
0.
0. What is our q of x? 1. The constant. What is our r of x? Cosecant of x. So is this a homogeneous equation or not? No, it is non-homogeneous. So the solutions of this is coming in the form of the general solutions of homogeneous equation plus a particular solution, right? So what is the solutions of the homogeneous equation? So if we have y double prime plus y equal to 0, then what is yg of x, c1, c2? Can you please calculate them? And how do you calculate them?
easily. First, the equation and its second derivative equal to 0, then it will be their minus, then it will be sine of
Yes, definitely. You are using guess and check, right? You say that sine and cosine satisfy here.
Yeah.
And since they are linearly independent, then the general solution is linear combination of sine of x and cosine of x. You're definitely right. But
the particular side.
if it was not a game of guess and check, how would you have solved this?
Making another equation.
No, what kind of an equation do we have here? We had two special classes of equations that you can solve, right? In your homework exercises, you have seen some special cases of Legendre's equations, Bessel's equations, but we haven't yet talked about them, okay? In general. The general things that we have talked about is the second order linear equation with constant coefficients. How did we solve them? We solved them by finding or writing down the characteristic equation, finding the roots, and based on which one of the cases it is. Okay? And also we have talked about Euler-Cauchy's equation. Which type of an equation is this? This is an equation with constant coefficients, right? So what is the characteristic equation of this? M to the power of 2 plus 0 times m plus 1 equal to 0. From here, what do I have for m?
Isn't it not real?
Yes. Okay. So what is our general solutions as we have discussed? Our general solution is going to be e to the power of ax, which is e to the power of 0x, times c1 cosine of bx. Yes. B is 1, A is 0. 1 times. Okay. Cosine of x plus c2 times sine of 1x. And if you see, this is equal to 1. And, okay?
That's it.
You see? You just need to understand what type of equation you have. Okay. But my problem is not really in finding the general solution of this equation when I reduce it into a homogeneous equation. This we have already talked. Our problem is not here that how can I find this yp of x? Does the method of undetermined coefficients work here?
Wouldn't it be something like a sine b?
Is this side something of exponential function or a combination of sine and cosine? This is 1 divided by sine. Or, okay, not go over there yet. Sine of x and cosine of x themselves. A linear combination of sine and cosine. Is it something like this? No. This is not a sine and linear combination of sine and cosine. Is this a polynomial? So it is better not to use the method of undetermined coefficients. Okay? You may use it, try to find a times cosecant of x or something like this, but maybe it is not going to work. Because taking derivatives of cosecant, first time and the second time, it is not turning the function into the types which are very similar to this one. You're changing the type. So it is not a good idea to use a method of undetermined coefficients. But, do I have two independent solutions here for the homogeneous equation? Yes, I have it. Which means that I can use the method of variation of parameters to find the particular solution. How can I do it? We assume that our particular solution is going to be v1 times y1 plus v2 times y2, right? This is our case. What is our set of equations? Or if I write it as in this matrix form, y1. What is my y1? It's called sine of x. Okay? What is our y1? Sine of x. What is the derivative of sine of x? What is y2? Cosine of x. What is the derivative of cosine of x? Minus sine of x. Okay. I have v1 prime, v2 prime equal to 0 and r of x. What is r of x? Cosecant of x. How can we find v1 prime and v2 prime? You just need to use Cramer's rule, right? And what is that? First, let's calculate the Wronskian of these two functions. Wronskian of y1 and y2. Can you please tell me what is the non-skin of these two functions? Or what is the determinant of this matrix?
Minus sine square x minus cosine square x.
Which is equal to, this is going to be minus sine squared, let me write this here, minus sine squared minus cosine squared.
So minus 1.
Yes. Okay? So I'm just going to multiply everything with a minus 1. I need to calculate the determinant of what? Since I'm looking for the v1 prime, or the first variable here, I need to replace this with the first column. So it is 0 cosecant of x, cosine of x, minus sine of x. And what is this determinant? 0 times minus and 0 minus cosecant times cosine.
This will be a cotangent.
Let me keep it as this. Cosine of x times cosecant of x, which is 1 divided by sine of x, right?
Wait.
Yes, it is minus cotangent of x.
Sorry, but there's another minus, so it will be a plus.
It will be a plus. Yes, with this minus 1, we have a plus. It's cosine divided by sine of x. Good? Now, what is my v1? It is the integral of cosine of x divided by sine of x dx. And what is this equal to? Do you see the derivative of denominator in the numerator or not?
Yeah, but with a minus.
What is the derivative of sine of x?
Oh, right, right.
So this is ln of sine of x. Let's keep it as this. What about v2 prime? This is going to be determinant of, since I'm looking for the second unknown, in this matrix I need to replace the second column with the right hand side. So it is going to be sine of x, cosine of x, 0 cosecant of x divided by minus 1.
Minus.
And what is this equal to? Yes, sine of x multiplied by cosine of x, which is sine of x multiplied by 1 divided by sine of x. This is 1 minus 0. Okay? I think I'm writing myself a lot anyhow. What is y2? Integral of minus 1 to x, which is going to be minus x. Here again, we are suppressing the constant of integration. I'm not writing plus c because we are searching for a particular solution, and particular solution does not have any C1 or C2 or this kind of coefficients come with it. We already have our C1 and C2 in the general solution. Okay? So I have my V1, I have my V2. Then, what is my YP? My particular solution for that equation?
And then sine x, sine x.
V1 times Y1, which is this one multiplied by the sine of x.
Sine x and then sine x.
Sine x ln sine x plus V2 times, which is minus x, minus x cosine of x. So, what is the general solution of this non-homogeneous equation? Our solutions are C1 sine of x plus C2 cosine of x plus sine of x multiplied by ln of sine of x minus x cosine of x. Okay? If we select C1 or C2 any numbers. For instance, let's select these two equal to 0. Are we going to get this, or is there any selection of C1 and C2 as numbers such that this term is included here? If you check, you will see that it is no. No matter what kind of C1 and C2 you select, this part of the solution never includes this part. Okay? Good. We have one more method to talk about, and it is the method of the operator method of Heaviside. I'm leaving it for the next week because we are going to have a lot of exercises related to these topics that we have studied today. Next week we are going to talk about this operator methods, higher order differential equations, and higher degree differential equations. I will just give the generalization of what is going to happen, especially in the cases that coefficients are constants. Then we will start our power series solutions to our, yes. Because solving the second order differential equations is not that much easier, as you have seen, except for the special cases like equation with constant coefficients or the Cauchy equation. And for other type of equations, we need to some kind of get help from these infinite processes, and the power series are going to be super useful for us. So anyhow, thank you very much. If you have any questions, please ask. Otherwise, in this last half an hour, we can also talk about the application of this second order differential equations. Okay? Or we can have it for some other day. Or you can also do some research about these problems. Because, you know, we are studying second order differential equations, right? But the problem is that, do we really have models of physical problems that they involve the second order differential equations? One possible project for you that you can think about, I'm also going to give you some reading material, is about vibrational problems in mechanics. Can you please listen to me? Can you please listen to me? Dad! Hello! Just 2-3 minutes and then... Okay. The last thing that you need to be aware of, and I would like you to make some project about it, is that the application of second order differential equations. One possible application is the vibrational problems in mechanics and especially in electrical systems. Okay? If you're modeling this kind of RLC circuits or vibration of problems, then you're going to see that the second order differential equations popping up. It is a good project for you to work about them and also come and talk about your results or solve some problems. Okay? I'm completely okay with that to accept that as your projects. Also, we can use Newton's second order differential equations and Newton's universal gravitational law in order to deduce the Kepler's law about the motion of heavenly planets. Okay? This is also another subject. At the rest, I would really love to talk about this. That is why I'm saying that, okay, let's talk about astronomy and this kind of thing. But unfortunately, we do not have that time today. So maybe one evening we can sit and talk about this kind of problem. But this is also a good research problem for you that you can also try to look at it. Okay? And if you again come up with any problems that you say, okay, this is a physical application and this is modeled by a second order differential equations and so on, it is also super good. Just let me know about it. Okay? Do you have any questions? Var mıdır sorumuz? Okay. From the next week, I really would like you to write down your solutions for the homework exercises and bring it with yourself to the classroom. I'm just going to collect them and give you points. And maybe if you're not going to bring them, I will just add them -5, -10 or whatever, okay? So to have a negative addition to the equation as such.
So we can also calculate deadline is tomorrow.
Yes, deadline is tomorrow, but for the next week it will be in the classroom.